Hi guys, greetings of the day. Myself Vijay Vardhan. Welcome to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 28, which is based on compensated flow control valve. As mentioned in previous slides and the sessions, the discharge of the fluid through the passage is also affected by pressure and temperature with the non-compensated flow control valve. Flow rate can vary at a fixed opening due to either change in pressure or temperature, or it could be even both. This makes a good flow control valve provided the load does not change very much. However, if the load changes, or the temperature of the fluid changes, the amount of fluid flowing through these valves changes for particular opening. This in turn varies the speed of the actuator. The flow will increase as the load decreases and decreases as the load increases. Similarly, as the temperature increases, viscosity of the fluid decreases and hence the flow increases, and as the temperature decreases, the viscosity increases and hence the flow decreases. To achieve constant discharge of flow, the flow should be a pressure compensated or temperature compensated or even both. Such flow control valve is called as compensated flow control valve, and in such a valves, compensation automatically changes the valve adjustment opening or maintaining constant pressure drop across the orifice to provide a constant flow. Accurate control of machine tools and other equipment require a uniform speed free from external resistance and temperature influence. To achieve the requirement and to provide adjustable stepless speed control over a wide range of operating conditions in a hydraulic system, one can think of pressure and temperature compensated flow control valve. These valves allow a constant and required flow rate of oil immaterial of pressure drop and temperature across the valve and the change in fluid temperature. And these requirements can be achieved by maintaining a constant pressure drop across the valve by adjusting the throttle is called pressure compensated flow rate. And the other one is adjusting the throttle for a variation in temperature of fluid is called temperature compensated flow control valve. And now the methods of flow compensations are as follows. The different methods of pressure compensation flow or bypass type and the restrictor type. And the pressure compensated flow control valve, the pressure compensated flow control valve automatically compensates for pressure changes by adjusting the throttle of the valve for any changes in workload by maintaining a constant pressure drop across the throttle for a given flow. Now let us understand the methods of one by one. So first one we will discuss bypass type. The figure on the left hand side shows a hydraulic circuit with an adjustable throttle and a spring loaded bypass valve. Since the spring of the bypass valve is light, the valve will start, that is nothing but cracking, that is nothing but opening when the pressure at inlet reaches the set pressure P1. This system will not move very heavy load. However, if a pilot line is connected between the outlet of the adjustable throttle and bypass valve, then the cylinder load is added to the spring force end, hold the bypass valve closed. As long as the pressure difference across the throttle is less than P1, the bypass valve will remains closed, immaterial of the external load increase. However, as throttle starts to close to limit the amount of fluid flowing into the cylinder, there will be an increasing in pressure ahead of throttle. This results in opening of bypass valve just enough to keep the pressure across the throttle at P1, which you can see the figure on the right hand side shows a bypass valve for a variation of external load on the higher side. Then coming to the restrictor type, in this case also the flow is maintained constant by maintaining constant pressure drop across the wall immaterial of the load, and now figure shows the device for such an operation. The orifice is made in a shaft by forming a notch. The shaft rotates and varies the orifice size and the flow according to the opening of the orifice. The pressure drop across the orifice is the difference between outlet A and inlet B at the orifice. The pressure at A is the pressure in conjunction with the spring pressure causes a downward resistance for the upward pressure at B. The land moves up and the flow reduces due to blocking of passage at B. Similarly, if the load at A increases, spring moves the land downwards, increasing the passage and hence the flow at B. The land thus moves up and down and settle down. This is about the restrictor type. By this, we have reached the time session allotted for this. Thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for further discussion. I will answer all your questions related to the topics covered in this session. And don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan.